Okay, hello guys. So welcome back to the next topic that we are going to talk about today in this chapter, pressure. Okay, so in the last two classes, we had discussed about pressure in liquid and atmospheric pressure. Today, we are going to focus in gas pressure. Do not worry, this is not a very long topic, but it is related to atmospheric pressure. So if you understand the concept of atmospheric pressure, you don't have problem in understanding gas pressure. Now, for this topic, you only have two objectives, two learning standards. Okay, so one is to determine the gas pressure by using manometer, and the other one is just to solve the problem by using in the concept related to gas pressure, okay, in daily life. Right now, let's proceed up. So you know what's a manometer right now? You had the experiment that you did in the last topic about atmospheric pressure where you use a U-tube. So if you look at this diagram, this is a manometer. In this manometer, I also have a U-tube here. So this manometer consists of a glass U-tube. So this apparatus is actually used to measure pressure. We specifically use this to measure gas pressure. Okay, now next one. Now, how are we going to use the manometer to measure the gas pressure? Now, basically, it's like this. So before we connect it to the gas, this is a U-tube, right? So before we connect this one to the gas, we have atmospheric pressure acting on the water. So this is what you know when you learn about gas pressure. Sorry, about atmospheric pressure. So you know about that. Then after that, we're going to connect this one to the gas. For example, I install this one with a syringe. You know a syringe, right? If we pump it, the gas will go inside. So when I put it connect it to the gas supply, you can see that when the gas is being supplied to this side, okay, the gas will push it here. So the gas that you push here, you are going to use P is equal to H rho G to determine the gas pressure. So that's how it is. Okay, now let's look at how we use the equation and formula to answer the question. Now here, see here. So initially, the pressure at A is equals to the gas pressure P. Okay, you see here. Initially, I have atmospheric pressure where both sides are the same. Then after I supply the gas, you will see P for air here and also the atmospheric pressure. So what I have here is the pressure at this A is equal to the gas pressure. Okay, so to find the pressure at B, okay, at B is actually the pressure due to the water column H, means that this pressure plus the atmospheric pressure. Again, I repeat, for this point B here, the pressure that you have here is H rho G here, plus the atmospheric pressure. But because I am using the centimeter water as my unit, that's why I have H centimeter water plus atmospheric pressure. Now, if you don't understand, I'm going to explain. You ask me in class and I'm going to explain it again. Okay, so basically this is what you have here. Then point A and point B are at the same level. Therefore, the pressure at A is equal to pressure at B. So to find the gas pressure is actually equals to H centimeter water plus atmospheric pressure in centimeter water unit. Okay, the unit for atmospheric pressure is centimeter water. Now, you remember, right, in the last class when you learned about atmospheric pressure, you have few units that you learned. First one, the Pascal, and then millimeter Mercury, millimeter water, and also MBAR. So that's what the thing that you have. Then here, I'm using water in my manometer. That's why I'm using the unit of centimeter water. Okay, please remember this atmospheric pressure is in centimeter water. Okay, now I move on. So the height of the water column represents the difference between the gas pressure and atmospheric pressure. So this is what you have. You learn about the atmospheric pressure in the last topic. And then you remember, right, when you did the experiment on the Thistle funnel, when you put the Thistle funnel in and then you can measure the difference, right? By using the Thistle funnel, you can measure the pressure in liquid. So actually we are using the same concept, just that this time we are supplying the gas into the manometer. Okay, they are the same. All right, now I move on. So another learning standard that you have to know here is you have to know how to solve problem in daily life involving gas pressure. Now this is the example. So figure shows a mercury manometer connected to a flask with compressed gas. So atmospheric pressure, you know that the atmospheric pressure is 76 centimeter mercury. Density of mercury is rho is equal to 13,600 kg per meter cubic, and a gravitational acceleration is 9.81 meter per second. What is the pressure of compressed gas in centimeter mercury? Now let's see here. So this is the first question. So what do you have here? So first thing is, I know that the difference of H column, is 40 centimeter. And then my atmospheric pressure is 76 centimeter mercury. Okay, so now what is the pressure of the compressed gas in centimeter mercury? So the answer will be H plus atmospheric pressure, where you have 40 plus 76 equals to 116 centimeter mercury. This is still easy, very easy. Okay, next one, the question asks you, calculate the gas pressure in Pascal. Now, how to convert centimeter mercury into Pascal? I hope that you remember. Okay, so I'm going to use this one in this question, where you have P is equal to H rho G. You know that H is 116 centimeter, where you find it just now, and then you have 1.16 because Pascal you must find in SI unit. That's why you have 1.16 meter, and then my density of mercury is 13,600. And then I have my gravitational acceleration is 9.81. Then I put it together, I have 1.55 times 10 to the power 5 Pascal. Okay, this is what you learned in the previous class. So I think that you should be able to understand this one easily. Right, next one. Will your answer in A and B change if the glass tube of the manometer has a larger diameter? What happens if, let's say, you have a larger diameter? So here's the answer. The answer obtained in A and B will not change because the pressure in liquids does not depend on the surface area. Remember, right? When I teach you about pressure in liquid, I gave you the diagram where all the things, you have different shape of the tube, and then after that, the water is in static. So the pressure will be the same. So that's why you will have no change, okay, in the pressure, because the pressure in liquid does not depend on the surface of area. Okay, all right, now I move on. Next one. So this one is another one. You see, let's look at the diagram properly first, where you have an air here. Okay, and then this is a locker here, screw or lock here, and then after that the air supply, and then it goes in here and it push this one down. That's why this is another manometer here. The air will continue to move. Now, figure shows a mercury manometer used to measure the pressure in an airflow pipe. Okay, again, in an airflow pipe. So what is the difference between the air pressure in the pipe and the atmospheric pressure in centimeter mercury? Now, again, what is the difference between the air pressure in the pipe and the atmospheric pressure in centimeter mercury? So I have my information, the density of mercury and the gravitational acceleration. So the difference in pressure is equals to the height of mercury column. So which is 25 centimeter mercury, right? Easy, right? Then, okay, the atmospheric pressure in centimeter. What is the difference? Okay, I repeat the question now. What is the difference between the air pressure in the pipe and the atmospheric pressure? Because the difference here, you remember, right? In this view, in here, okay, I remember. Okay, here. Let me explain here. So this one is the difference between the atmospheric pressure and also the gas pressure. So that's why the H column represent the difference. Okay, so that's why you have 25 centimeter mercury there. Okay, now, so this is what we have. Next one. If the atmospheric pressure is 75 centimeter mercury, what is the air pressure in the pipe in Pascal? Same, you have all the information that you have. So you know that to find the pressure, okay, pressure, P is equal to H plus atmospheric pressure. So you will have 25 by 75, I have 100 centimeter mercury. But my answer one in Pascal. So that's why you have to convert it. Where you have 1, okay, this 100 centimeter you convert into meter. I have 1 meter times 13,600 multiplied with 9.81, and then I get 1.33 times 10 to the power of 5 Pascal. So this is what we have. Okay, then that's all for the topic about gas pressure. Okay, see you soon in the next topic. Bye-bye.